we've got this collection of 15 numbers, and 3 people, randomly and independently, are going to choose one of these numbers. So, part A. Let's look at part A here. Part A, we want to know, what's the probability that the second 2 people who choose a number, choose the same number as the first? So maybe it's something like this. You got a first person picking a number, then a second, then a third. So we got a first person picks a number, then a second person. Now, the first person is going to pick one of these numbers. So there's 15 numbers, and that person can choose any one of those 15. Now, once that person makes a choice, say that person chose one of these particular numbers, like, say, 11. All right, so, that's supposed to be a 10, I think. So, but anyway, first person chooses one of these numbers. Now, what's the probability that the second person matches that number? Well, there's only one of those numbers, and there's 15 choices. So the probability that the second person matches the first is 1 out of 15, and the probability that the third person matches the first is also 1 out of 15. So this is going to be 1 times 1/15 times 1/15, which turns out to be 1 over 225. You could leave it like that, or you can convert it to a decimal as 0.0044, 0.0044. So that's going to happen maybe tenths, hundred thousandths. Say if we just go to thousands, about 4 times out of 1,000 that would happen. Now in 16, we've got a box containing flash drives, so I'm going to summarize this by drawing our box. So there's 5 defectives. We've got 5 defectives and 7, how about D primes, non-defectives. So N altogether is 12, and we're going to randomly select a drive from a box and not replace it. Then we'll choose a second drive. Okay, so I'm sure you can hear my cat in the background. This is my cat here. His name is Bones. And I don't know what he wants, but he wants something. But let's go on and see how far we can get. So anyway, we're going to choose, what are we going to do here? He's got me distracted. So we got 5 defectives, 7 non-defectives. We're going to choose one and not replace it. Then a second drive will be selected. What's the probability that the second drive is defective? Here's what we're looking for. What's the probability that the second drive is defective? So what we want is the second drive to be defective. Okay, well, how can this happen? In sequential events like this is a good place to think about drawing a tree diagram. Let's start here, and we're going to branch out this way. And so what can possibly happen here? Well, you make your first draw. Right, here's our first draw, and what could happen is we get a defective on the first, or we could get a non-defective on the first. Now, the probability associated with each event is this. What's the probability of getting a defective on the first? Well, there's 5 defectives and 12 altogether. So the probability of moving up this branch is 5/12. So this is going to be 5/12. And this non-defective on the first, that would be 7/12, right? Because they have to add up to 1, and you got 5 defectives out of 12, 7 non-defectives out of 12. So now you've made the first draw, so let's move on from the first draw. So out of the first draw, we'll make a second draw. Now what could happen in the second draw? We could get a defective on the second and a non-defective on the second. Now what's the probability of getting a defective on the second? Let's see what this branch is. So here's what we did. Back up here. We randomly selected from the box, and then we did not replace it. So there were 12 to begin with. We took one out, so there's only 11 left. There's 11 left. Now, what's the probability of getting a defective? Well, we got a defective on the first, right? So we're assuming we got a defective on the first. We tossed that one out. So there's only 4 defectives left out of 11 total. And then the non-defective, well, there's still, what was that? There's still 7 non-defectives, but only 11 drives. But now let's go down here. What's the probability of a defective on the first? 7/12. Now move on from there. We take our second draw, and what could happen? We could get a defective on the second and a non-defective on the second. Now the probability of getting this node right here, a defective on the second, given that we got a non-defective on the first. So there was 12 to begin with. We removed a non-defective, so there's only 11 left. And since we removed a non-defective, there's still 5 defectives left. And then down here, there's only 11 flash drives to choose from, and we want a non-defective here. But what happened is this: we got a non-defective on the first, and we tossed it out. So out of the 7 to begin with, we tossed one out, so there's only 6. Now what we want is a defective on the second. So here's how you can get a defective on the second, right there and right there. So what has to happen? How do you get here? You have to go up this branch and this branch. So you have to go here and times here. So what you get is 5/12 times 4/11, or you can go this way, down here and here, to get a defective on the first and a non-defective on the first and a defective on the second. So if you go here and here, you're moving along 7/12 and 5/11. So what I'm going to do here is I'm going to just add these. And when I added those, I got 416666 forever. So I'm going to round off to 0.4167. So what that means is that if we were to actually do this experiment, pick one, pick another, about 42% of the time, we would get a defective on the second draw.